Okay, so in this lesson, we're going to wrap up chapter 1. We have a problem here on screen. We're going to go through it, and as we go through it, we will revisit the 4 counting methods that we had learned in this chapter, and the conundrum that will be presented from this example. So let's just read through the problem, work it out, and then we'll discuss what's going on. Your high school math club is holding an election for club president. The candidates are Alicia, Barry, Chris, and Derek. They are represented as choices A, B, C, and D in the preference schedule shown below. So we're going to work this out 4 times, first by the plurality method, second by the board account method, third using the plurality with elimination method, and finally the method of pairwise comparisons. So the plurality method simply takes a look at the first place choices. So we only need to look at this information of the table. And based on this information, we see that A has 14 first place votes. We see that B has 4 first place votes. C has 10 plus 1, so 11 first place votes, and D has 8 first place votes. So the plurality method here has given us a winner of A. A has 14 first place votes. Now, do we classify A as a plurality winner or a majority winner? So to see this through, we want to determine how many votes are needed for a majority. So altogether, the number of voters are the sum of these numbers in the header. So 14 plus 10 plus 8 plus 4 plus 1. We have 37 voters. And to have a majority means greater than 50%. So 50% is equal to 18.5 votes. So a majority is greater than 50%. A majority is greater than or equal to 19 votes. Since A has less than a majority, we call A a plurality winner. So in this second example, we're using the board account method. The board account method sets up a point system. So last place is worth 1 point, third place is worth 2 points, second place is worth 3 points per vote, and first place is worth 4 points per vote. So if we were to do this, we would say that A has 14 times 4 votes. Add to that, here A has 10 times 1 vote, or 1 point per vote. And then in the next column, it's 8 times 1 point per vote, then 4 times 1 point per vote, then 1 times 1. So we see that A has 79 points. So the board account method is a point system, and we will continue to work this out for each voter. Now, the nice thing is we saw that A won as the plurality candidate, but notice how even though A was the winner by plurality, all of these other voters put A as their dead last choice. That means that even though 14 individuals voted for A to be their first place choice, we have more voters saying that that is their last place choice. If we look at this, that's 23 saying that's the last person we want. A plurality method would not have been the best way to choose a winner. So we're going to see what we get here with the board account method now that we're using point systems. And we're taking B in each column, and we're just taking the number of votes and multiplying it by the number of points in that position. So we see that B has 106 points using the board account method. Let's check the other candidates. So C is very close with 104 points, but B is still in the lead with the border count method. So we see that the winner here is candidate B by the border count method, and notice that A came in last place. I'm going to go back to the previous slide. Here, using the plurality method, meaning using the method of choosing just first place votes, A would have been the winner. But through further examination, we see that A is the last choice for the majority of people voting. Yes, I use the word majority because this adds up to 23, which is greater than 19. The majority of voters put A as their last place choice. And in the border count method, the calculations saw that and took it into account and noticed that A came in last place because the majority of voters put A there. Our winner is B by the border count method. Again, this is using a point system. It's taking all of the voters' preferences into account. And now we look at our next method, which is called plurality with elimination. Again, this also has a name known as instant runoff election. And it's called that because in many states and localities, you need a majority to be declared a winner. So I believe Georgia is one of the states where if their senators don't get a majority, then they eliminate those candidates with the least first place votes and they rerun the election until somebody wins over 50% of the vote. So if we go back to this, we can see that A has 14 first place votes, B has 4, C has 11, and D has 8. So this is round one. And the plurality with elimination method says eliminate the person with the least first place votes. So we go through the table and we eliminate that candidate. And we say, where do those 4 votes, since candidate B had those 4 votes, where do they go? Well, they go to the next person in line. And we said that this is because of the transitive property. If B is greater than D and D is greater than C, then we can say B is greater than C. And this is true for the relationship of all of the candidates on that ballot. So next in line gets those 4 votes. That means we're going to bump candidate D's votes up by 4. No one else saw a change. So round 2, A still has 14 because it didn't earn any votes from a candidate dropping out. Candidate C still has 11, didn't earn any votes from a candidate dropping out. But candidate D now has 12 because it earned 4 votes when B was cut from the election. And I'm just going to drop back to our first example. We see that a majority is 19 or more. This is the same example. We're working it over and over. So we need to keep going until one of the candidates has 19 or more votes. No one has that. So we do another round of elimination. And we say, well, who's got the least votes now? Well, that's candidate C. We're going to take C out of the election. And after we take C out, we say, where was C in first place? Well, in column 2, and the next candidate in line for C's votes is D. And then we go to column 5, and we see that after C is removed, the next candidate in line to receive C's votes is D again. So 11 more votes get added to D. So we now see that D has 23 votes, which is a majority, so D is the winner. This is the same exact preference schedule. And let's go back. The first method, we used plurality, A was the winner. The second method, we used the border method, B was the winner. The third method, we used plurality with elimination, and D was the winner. Who do you think is going to win in the fourth example? Method by pairwise comparison. So A versus B, A versus C, A versus D, And then we want all of the possible pairs, B versus C, B versus D, and C versus D. We see that we have 4 candidates. Pairwise means choose 2 at a time. So a combination of 4 choose 2 is 6. We have the 6 pairs. We know that we've accounted for them all. We double checked it with our combination math. And now we just look at A and B and say who would win these 14 votes. That would go to A. We go to the next column. Who would win between A and B those next 10 votes? That would go to B. We go to the next column. Who would win between A and B those 8 votes? And just let me go back to recap. What is a majority for this election? A majority for this election is 19 or more. So as soon as a candidate gets 19 or more, we can say they're the winner in the head-to-head. So far, B has 18. That's not enough. We have to keep going. But we see that B gets 4 more. B wins this first head-to-head comparison. That's worth a point. Now we go to the next head-to-head comparison, A versus C. And because A is in dead last in all of these, I know that A is going to lose to anyone else in the competition. So now we go on and we say, all right, let's compare B to C. So comparing B to C, those first votes go to candidate B, that's 14 votes. Between B and C, those 10 votes go to C. Between B and C, 8 more votes go to C. Here we see 4 votes go to B. It's 18 to 18, and that last vote goes to C. That's the 19 votes needed for a majority. Now we're going to compare candidates B and D in the pairwise comparison. B versus D, so 14 votes go to B. B versus D, 10 votes go to B. That is above the 19 needed for a majority. There's no way for D to win, so B is the winner there. And now we can go to C versus D. C versus D, 14 votes go to C. C versus D, 10 votes go to C. C won the majority. Now we can do a tally, A, B, C, D, and say how many competitions that each of them win. So the first competition goes to B, the second competition goes to C, the third one goes to D, the fourth one goes to C, the fifth one goes to B, and the sixth one goes to C. We see that we have 0 points, 2 points, 3 points, and 1. And that means in a head-to-head competition, that means if there were just 2 candidates and no others to detract votes, C would win against any other candidate. So C got 3 points, and C is the winner. So we used this same table in all 4 methods, and we used 4 different counting methods, and we got 4 different winners. So what is the conundrum that comes up? What is it about fairness that comes up? And the fairness of an election is determined by the rules set before the election takes place. The outcome and fairness of an election are subject to the rules of the election. And we just saw with our preference schedule that we got 4 different winners based on the rules that we establish ahead of time. So if we say plurality is how we're picking our winner, then A would be the winner, and that's fair. There's no reason to rebel against that. Even though the majority didn't want A, if that was the rule set for the election ahead of time, that is how you choose your winner. In the second example, if the board account method is the rules of the election and that was set forth before the votes were cast, then B is the winner. And that's fair because those were the election rules set forth for the voters. Same is true for each of these others. If we use instant runoff where someone has to get a majority of first place votes by eliminating candidates, Then we got D as the winner. And then finally, if we said eliminate choices, third and fourth party choices, and just compare head to head, we see that C would be the winner. And this is the results. So the rules have to be established before an election, and we have to accept the outcome of the election based on those rules. So here are the 4 fairness criterion that are listed for the chapter. You can read through these, pause the video here, read through them. The textbook goes through examples where each of these were violated. We examined the majority in the Condorcet criterion in depth in class. I'll leave the monotonicity criterion and independence of irrelevant alternatives criterion up to you to read and look at examples of. If you have questions, you can ask me about them. We can work them out together. But if political science is a subject that you're interested in, I would definitely review all of these, ask questions. These are the fairness criterions that each of these election methods have violated in some way or another. And that's why we come to the final culminating statement of the chapter, and that is Arrow's impossibility theorem, which says that there is no single method for counting votes that will guarantee a fair outcome 100% of the time. That being said, election results are fair. We're not saying that never are election results fair. Most of the time they are fair. And even though we explored a bunch of different methods for counting votes and we saw how they can violate fairness criteria, that doesn't mean they're always going to violate fairness. So they can be fair. Most of the time they are fair. But there is always an oddball example that illustrates how, no matter how you count the votes, we can find a way that it can result in an unfair outcome. Okay, that concludes chapter 1. Complete the test review. We'll be testing on it soon. Let me know if there are questions.